Okay. Good afternoon. Myself Sreeja Pekkat, who is the course instructor for the MOOC on engineering hydrology. So this is our 5th week regarding this particular course. So I hope you are following the course carefully, and we have completed 4 weeks in the last 4 weeks last week, and 5th week is running now. So hydrology, as from the beginning, this is a fundamental course for civil engineering students, agricultural students, all should have the fundamental knowledge about the engineering hydrology. So hydrology is the science, as we have started with the course, it is the science which deals with the water, study of water. So as we all know, from school days onwards, we are studying water exists in 3 forms, that is gaseous, liquid and solid form. So in this study, based on the presence of water on Earth, it has been divided into 3 parts: surface water, atmospheric water and subsurface water. And in the first lecture and within the syllabus itself, it is very clear that our aim is to cover the surface water. Subsurface unsaturated zone we will be covering very superficially, and groundwater part is not coming under the scope of this particular course. Surface water and atmospheric water will be covered in detail. So by this week, that is the 5th week, you might be into the subsurface water. And initially we have started with the preliminary understanding of the hydrology course. We have in the first week itself, we have understood the concept related to Reynolds transport theorem. And Reynolds transport theorem is very, very important as far as any fluid flow is concerned. If you're going to derive the fundamental equations such as mass conservation equation, momentum conservation equation and all, we will be making use of Reynolds transport theorem, which is based on we have derived the expressions and all based on the Eulerian principle. This is connecting our constant mass Lagrangian and Eulerian principles as far as the fluid flow is concerned. So by making use of the derived Reynolds transport theorem, we have derived the mass conservation equation, we have derived the momentum conservation and energy conservation. By making use of the total energy, we just saw the expression corresponding to that. With that, we have concluded some of the examples also we have covered related to the conservation principle. Very basic numerical problems we have solved. After that, we have moved on to week 2. Week 2, we have started with the atmospheric water. Atmospheric water started with the preliminary understanding about the atmospheric parameters, which we should have idea when we study regarding precipitation and other hydrologic processes. So in that, by making use of the RTT concept, we have derived the precipitable water which is present in the atmospheric column. And then we have moved on to have the understanding about the precipitation and how the water droplets are falling down. What is the terminal velocity with which it is falling down? Those things we have already observed. So terminal velocity concept not only regarding the water droplets, within the fluid also, how it is falling down. Those concepts you might have studied in fluid mechanics. Similar concept we have seen in the case of hydrology also. After that, we have moved on to the thunderstorm cell model. Thunderstorm cell model is giving us an idea about the intensity of rainfall. It is applicable to rainfall, not applicable to all kinds of precipitation. It is applicable to rainfall. So it will be giving us how much will be the intensity of rainfall in a particular convective cell, the cell which we are considering, and the results which we have, the analysis we have carried out as far as that cell is concerned, it is based on the convective cell principle. That is, by means of the convective principle, the movement of the fluid is taking place within the cell, and we are getting the liquid form. Due to condensation, we are getting the precipitation. Then we have moved on to the topic of different types of precipitation and measurement of rainfall. Then we have seen the rain gauge network, and how to get the, if we are having in a particular location, we are having a number of rain gauges, whether those are sufficient or extra number of rain gauges are required. All those things with the help of examples we have covered, and how to represent the analysis of rainfall data, how it can be done. And for majority of cases, in a particular area, we'll be having certain number of rain gauges only. So depending upon the area, we have to make use of the average aerial rainfall. Different methods which are required for computing the average aerial rainfall also we have seen in the week 3 courses. Once precipitation related concepts over, we have moved on to evaporation. Evaporation is the process by which water is getting vapor converted to vapor. So different factors influencing evaporation we have seen. Based on that, we have prioritized the factors which are influencing evaporation. Then based on the factors which we are considered, we have made use of different methods, different approaches. One is based on energy balance method, and the second one is based on the aerodynamic method. As far as evaporation is considered, just vaporization of water is not sufficient. The water which is getting converted to vapor should be moved away from that location. So wind velocity is also very important. So in the first case, energy balance method, the radiation, solar radiation is the important factor. Due to the energy from the solar radiation, that is the main source of energy which is converting water to water vapor. So based on the solar energy, we have we have found out the expression for finding out the evaporation. After that, by incorporating the wind velocity component and humidity, specific humidity which is contained within the moisture which is contained within the atmosphere, by combining these two things, we have developed the equation based on the aerodynamic method. But when the process evaporation is concerned, all these factors, that is solar radiation alone is not sufficient. Solar radiation along with wind velocity and also specific humidity together has to be considered. So combined method also we have covered, and based on that, some of the numerical examples which gives an idea about all these methods also we have seen. After that, evapotranspiration and some of the examples we have covered. There ends the case with the module related to atmospheric water. Then the next module is related to subsurface water. Subsurface water is the, I am again repeating, in the course, beginning of the course also I have mentioned, the entire subsurface water will not be covered over here. Depending upon the water table location, the region is divided into two parts, saturated region and unsaturated. Unsaturated above the groundwater table, saturated below the groundwater table. So here in this course, we will be looking at, we'll be studying the unsaturated region only. Flow through the porous media will be covered. So some of the lectures related to that already covered. Today is Thursday. You will be getting all the 5, or you might have already gone through all the 5 lectures of this week. So this incorporates the preliminary understanding about subsurface. And we have seen very, very important equation as far as subsurface flow is concerned. That is our unsteady flow equation representing the flow through the porous media, which is known as the Richards equation. Richards equation also derived by making use of the RTT, Reynolds transport theorem. That is by making use of the RTT, we have derived the continuity equation and the Darcy's equation, which is indirectly representing the momentum conservation principle. Incorporating continuity and momentum equation, we have derived the flow equation corresponding to flow through porous media. One-dimensional unsteady flow through porous media we have covered. Then we have moved on to the topic of infiltration. Infiltration, how the water is getting infiltrated. In any layman point of view also, we are very much familiar with this process. Whenever rainfall is occurring, some amount of water is getting into the soil, moving into the soil. And after certain time, we are facing the problem of ponding. So when this ponding will be occurring and how long this ponding will be creating the water with a depth, after that it will be starting as an overland flow. For a long time, water cannot stand on the surface with a certain depth of ponding depth. So that ponding, at what moment, once the rainfall has occurred, after that, at what time the ponding of water will be taking place, all those things we have covered, and then we have moved on to the determination, measurement of infiltration, different experimental methods to determine infiltration we have covered. So those are the commonly used double ring infiltrometer, single ring infiltrometers, those things we have covered, and the empirical equations and the theoretical equations regarding the computation of infiltration. With certain equations we have derived and some other empirical equations we have seen, which are commonly used for the computation of infiltration. And regarding that, we have gone through some of the numerical examples explaining each and every concept clearly. And the important equation which we commonly use is the Greenamt equation for determination of the infiltration. That equation we have derived from the fundamental principles by making use of the continuity and the momentum equation. That is nothing but our mass conservation and the momentum conservation equations. So regarding all the up to that topic, that is up to this week, we'll be completing our Greenamp's equation. Next week, we'll be continuing with the subsurface water again, and we'll start with the surface water. Surface water, the overland flow modeling will be seeing overland flow, and after that runoff, all those details we will see in the coming lectures. And next week we'll be starting with the week 6. So this is a 12-week course. So almost midway we are here. So in case of any clarification required, you can ask me. For any queries, you can ask me. If any candidates who are attending this NPTEL MOOC course, who is there in live, can clarify the doubts. Manish Sahu, hello, good afternoon. If you are facing any problem with the course or any contents or any clarification regarding the topic till now which we have covered, you can clarify it. So in the Google form also, Excel sheet also, I didn't get any queries. So if there is any clarification required or anything to be, any doubts to be cleared, you can also send me email in NPTEL Gmail also, and in my personal email also you can send email. I'll be clarifying depending upon the whenever I get email, I used to. Okay, Manish, it's okay. So then whenever I get the email, I used to send the reply. Sometimes candidates may not be appearing in the live. some of the students directly contacts me. So in case anybody is facing problem, you feel free to contact me through my email number, email ID, which is given in my website, and also in the NPTEL site it is available. And this is a very basic fundamental course which is required for any study related to water related problems. This is not related to water quality, basically water quantity. So fundamental knowledge, any civil engineering student will be having the idea of having the basic knowledge from the fluid mechanics, fluid properties, all those things. After once attaining that knowledge, we are moving on to hydraulics, and hydraulics, then we are moving on to the field application, mainly covers under hydrology. So channels, overland flow, channel flow, overland flow, everything comes under this particular course. So overland flow we'll be starting in the next week, and after that we'll be moving on to channel flow. That is flow, how much discharge will be there at a particular location, how the flow can be measured in a particular river, what are the different methods for measuring the river flow. All those things will be coming in the coming lectures, we'll be covering in the coming lectures. So whatever a basic civil engineering undergraduate student is supposed to know regarding hydrology, all those covered in this syllabus. Whatever competitive examination, all those provide a syllabus. Based on that only the syllabus is prepared, and majority of the numerical problems also we have covered in that. Still you are facing any problem, please feel free to contact me. We are there to help you out. Now I think nobody is turned out and almost 16 minutes over. I am winding up the live session since no questions are there. Yes, this is enough for GATE exam. Manish, this syllabus is prepared based on GATE syllabus, but extra atmospheric hydrology part I have covered in this. That basic understanding is required as far as the hydrology civil engineering student is concerned, because so much of climate change related issues we are facing. For that we need to have the understanding about atmospheric hydrology. So the thunderstorm cell model regarding all the precipitable water, all those things are not coming under GATE syllabus. That thing extra I have added. Other than that, whatever important for GATE, this syllabus covers that. Those topics I have included in the syllabus. And some of the numericals also based on the GATE syllabus I have incorporated in the along with the concerned theory part. Infiltration, regarding till infiltration, if you have covered up to that, when you check you can see the similar kind of numerical problems which used to be asked for the competitive examinations. So since I didn't get any query in the Gmail and also in Google form, I think no more questions. Some of the questions I got in my personal email regarding rainfall calculation, rain gauge related, and the infiltration related. Those questions, numerical problems we have covered in the course content itself, and we have solved those type of problems. That is why I'm not explaining over here. When you check the course videos in YouTube, numerical problems I've already solved related to infiltration and also the rainfall, average rainfall computation, and regarding precipitable water. So those things still, even after going through the YouTube lectures or NPTEL lectures, still facing problem, you can contact me. So now here I am winding up the live session.